Good day, Mike Mata here. We're going to walk through a brief scenario looking at a security incident using Wireshark. So I pulled the traffic from Malware Traffic Analysis.net. Great place to get a lot of malware files. And I opened it in Wireshark, grabbed one of them, opened it in Wireshark, and the first place I go is statistics, conversations, and then I typically want to look at my TCP conversations by bytes. Who's my top talker? In this case, I see this 172.16.45.52. I am going to go ahead and just follow that particular stream. Let's just highlight him, click follow stream. And we can see he's sending a get for this video content, CA, poppies, Getty, RM, blah, 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 JPEG. So, could be malicious, might not. We'll just have to take a quick look. We'll see here in the 200 OK, it's responding back with, that's going to be 335,737 bytes. But what I'm looking at is right here. Was it good? Was it not good? Are we sending something we shouldn't be sending in an HTTP response, like an exe file, something like that? In this case, a JPEG, probably okay. So I'm going to close this real quick, and I'm going to take a quick peek. There's our get video. 200 OK. And if I look at the 200 OK, you'll notice a couple things in the HTTP response. There's actually a lot of information in here, and one of the key pieces of information is here is this content JFIF. And how does Wireshark know that, and is that good or bad? Well, you notice what's highlighted. The first byte there is FFD8FFE0. And how do we know what that means, and is that good or bad or indifferent? Well, I'm going to take you to a place. Gary Kessler, one of my favorite guys. File signatures. GaryKessler.net has this nice paper. You can sort through file extensions, and I'm going to do another video showing you how to look for DOS executables, anything like exe being downloaded. But here's the simple button, easy button, FFD8FFE0. We see that info. Oh, I don't want to do that. We see that information right there, highlighted FFD8FFE0. I'll try to highlight that. Right? I don't want all of it. So that's the information that's kind of telling Wireshark, that this is a JPEG. You notice FFD8FFE0, standard JPEG, JFIF image. The 2 bytes here, if we take a look at the JPEG image compression information, it tells us often that's 0010 followed by JFIF, which is exactly what Wireshark showed us. So if we look at that, FFD8, FFE0, 0010, and then there's our JFIF 4A46, 4946 in hex. And then again, displayed in ASCII. So we're going to probably guess that, that's okay. That's not malicious content. If we wanted to, we could export that content simply by clicking on Export Objects, HTTP. And if I have my settings, and of course I don't have my settings set up correctly, one of my frustrations with Wireshark, that's not a frustration, it's just, it is what it is. So I need to go back into my HTTP and change that setting. So hang on, let me do that here quick. So these are the settings in HTTP. I turned them off earlier, so I turned them back on here, and that will allow me to basically file carve that information. If I click File, Export Objects now, it should list them, all the objects instead of packets. That looks better, maybe. Let's go make that bigger. And let's go look for that one right there, was where that came from. Image JPEG, yep, there we go, 335,000 bytes. So We could save that, save as, and save that image if we wanted to save that image. Save it, and there we go. We would have it, and we could go look at it later if we wanted to. But enough of that. Let's cancel out of that. Clear that, and let's go look at the next stream that was our top talker. Conversations again. Go to TCP, sort by bytes, and we'll look at this next one, which is IP address 172.16.45.98. So let's go ahead and filter on that. IP dot address equals 172.16.45.98. And actually, before I do that, let me just go back. So sorry about that, but let me go back to that first one and show you one other thing. In that reply here, there's a lot of good information. The 200 OK, actually here in this user agent, I can do it with the stream. NT61, this tells us a lot of information about the client. If I look at the spreadsheet, NT61, that's telling us that this is a Windows 7 device. That's the operating system that is running and that is performing that request. So where you get that information, if you want that spreadsheet back out to my website, you're more than welcome to grab it. MNEX, again, grab the frame header there, and all that information is right there. So there's our user agent. Now let's go back and filter for that one particular IP address. And again, we'll just do IP adder, IP.adder equals 172.16.45.98. And we'll do TCP, or we could even do and HTTP, but I'll do TCP. Make sure we're grabbing all the good stuff here. I'll close that, and let's filter for that. Okay, and let's jump to the top of all this. We get a GET request for Microsoft, basically checking the network connectivity there, saying let's go see if our little NIC is connected, and we get the 200 OK back. Yep, saying we're good. Have to revalidate it again. Then we see a GET request for a GET raw for basically from what's my external IP. We see a response. Next we see the IP address right there, 173.66.46.81. Then we see a post, and it's going to post get key right here in this particular post. So the clients, let's go ahead and follow that stream. What the hey, Ray? Follow TCP stream. So we see the post here. It's content length of 8 bytes, and there's the post. Server said continue. There's the get key, and then it replies back with here's the certificate, end of the certificate, and then some other things happen. So let's cut that out of there. We're going to save this data as raw. We'll click on leave that as raw. We'll say save as, and let's call this raw key .text. We'll save that. And let's close that. And while we're taking a peek here at that post and the 200 OK, there was our post. We get some 200 OKs back here. We can actually see. Let's take a look at, actually, where's our post from the client? And we see this time the user agent is different. We have a Windows NT51 user agent. So if we take a peek at that, NT51 this is from a Windows XP machine. So we know we have two different Windows machines operating here. And let's jump back in. Some of the other info about that, the browser information in there is this Gecko and this Bon Echo. If we did a little search on this, That might prove to be interesting if you searched on bonecho/2.0.0, I believe. That's an older version of Firefox, Mozilla. So we see the browser information there. Again, the Windows version, all of that good stuff right there in that user agent. And again, let's go look at that key that we saw. We saved that out. Let's go take a look at that. Let's find that. Well, there's the file, the picture file there. We could actually go open that up and take a look at that if we wanted to, but we're good. Let's look at this raw key text file. So if we edit it and get rid of all the noise around it, we can probably paste it and put it, and let's make that bigger. So, okay, we don't need any of this or this. Oh, we want that. So we're going to delete that and then delete everything after the certificate and the certificate. And then we'll save as, well, we'll just name that number 2. So we know that's the one that's filtered or been edited. And save. Okay, so we have that. We could do a couple things with this. First, we could copy this information. Since we pulled that out of Wireshark, we could copy that first line and go Google search it. Let's go over here and open up a new Google search and paste that and do a quick search on that and see if we find anything. And we do, by golly. It says, you know, that key has been used in the Zyklon, ZYKLON malware. Looks like Arbor Networks has got a little write-up on that, as well as a couple of other locations. The second thing we can do with that is we can actually, whoa, look out. Where did we go? We can actually run that through OpenSSL as well if we wanted to. Just click on, I don't know what happened to that error. Okay, let's do OpenSSL, that certificate, -in, X509, -in, and then our raw text -2. Or no, wait a minute. I think I called it raw key. Raw key -2.txt. And text wiped to less. And we can actually see the certificate there, the SHA issuer.onion, not before, not after dates, the public key, and again the signature algorithm, that certificate that we just put up into Google to search. So a lot of good information that we can gain from Wireshark just by following streams and saving text. We can even look at that picture if you wanted to. That was saved there as well, that JPEG picture. So hope that's helps, been beneficial, and thanks for listening. And again, I'll try to do another video to show you a couple filters and Gary's signatures, looking for executables downloaded from malicious websites. So thanks a lot. Make it a great day.